Hey, this is Lance. I'm a software engineer at LangChain, and I'm very excited to talk to you about building reliable agents using LangGraph. So to kind of set the motivation for this, a solitary language model itself is a bit limited. It doesn't have access to tools. It doesn't have access to external context, like, for example, documents that are private to you or your organization. And it can't, in isolation, perform multi-step workflows. So for this reason, we've seen a lot of LLM applications use what you might think of as like a control flow or some set of steps around LLM calls. So this could be steps before an LLM call, like retrieving documents to pass to the LLM. That's what you might call RAG. It could be using an LLM to call external tools, which is common with agents. But either way, there's an LLM call with stuff around it. Now, this is what you might hear referred to as a chain. So chain is just some set of steps around an LLM call. Now, the nice thing about chains are they're reliable. So they'll follow the same set of steps every time you run it, and that's desirable for lots of applications. But there are cases where we want an LLM to be able to choose its own control flow or pick the set of steps to run in order to solve a problem. So you may want some applications that are adaptable. Let the LLM kind of choose what to do depending on the nature of the problem. Now this, in simple terms, you can think of as an agent. An agent is a case where the control flow of the application is defined, at least in part, by an LLM or language model. So you have fixed control flow, a chain, versus a control flow that can be in some part dictated by an LLM. That's an agent. So that's kind of a simple framing of how to think about agents versus chains. Now, a subtle point, but very important one, is there's lots of different kinds of agents. So, for example, in really simple terms, you can think about a router as a really simple agent. That's just where you allow an LLM to control one step in your flow. In this toy example, going from step 1 to 2 or 3, the LLM makes that choice. That's a kind of simple router. It's a very simple kind of agent architecture. On the other extreme, you can have an LLM that's connected to a large number of tools. The LLM can choose to invoke those tools in any order it wants. That's kind of what we might think of as a fully autonomous agent. It can be long running. It can choose kind of any trajectory through the set of tools. And that's an example of of an agent that has a much greater degree of control. So there's kind of a catch here. As you think about increasing the level of control that you give the agent, the reliability of the application often degrades. And so we saw this, 2 years ago or a year and a half ago. A lot of really charismatic projects came out like Baby AGI, AutoGPT. These are really exciting examples of long-running agents, but I think people did find that there's real practical challenge if you want to actually deploy them due to reduced reliability when you just let LLMs go wild with lots of kind of control over the application. So LangGraph is really a new library from the team at LangChain meant to kind of bend this reliability curve, allowing you to build kind of complex agents that have a large degree of control over applications, but that don't suffer from a significant degradation in reliability. That's kind of the motivation for what LangGraph is all about. So it's, again, balancing this reliability with control. We want to build agentic systems that have a large degree of control. We also want them and need them to be reliable so they can actually be productionized. That's kind of the problem statement. So what are the intuitions behind LangGraph? Well, the way to think about this is when you lay out kind of applications, you can think about some series of steps like we talked about. With LangGraph, you can really easily lay out these steps as a graph. Okay, so you can enumerate certain steps that you want your application to take. And you can also interject LLMs at arbitrary points to kind of control the flow of the application, give it agentic kind of behavior. So in this toy example, you go to step 1, and LLM can reason about going back to step 1 or going over to step 2. Now, the key kind of intuition behind LangGraph is you can express these workflows or control flows as graphs with nodes and edges, where nodes represent different steps in your application. Edges represent connectivity between those steps. So LangGraph really simply lets you lay out these workflows as graphs. And it has a few different pillars that help to kind of bend this reliability curve and allow you to build kind of agents that have a kind of high degree of both control and reliability. The pillars, which we'll talk about in some detail, are going to be persistence, streaming, human-in-the-loop, and kind of advanced controllability features. LangGraph also comes with an IDE called LangGraph Studio, which is a very nice tool for visually looking at your agents, debugging them, and otherwise kind of visually seeing the flow of the application as the agent's running. And it's also important to note before we dive into some of those pillars that LangGraph plays very nicely with LangChain. So LangChain is an independent open source library that offers a large degree of integrations for popular components for building LLM applications like LLMs, vector stores, and other things. LangChain gives a common interface for these components and offers many integrations. And these components can be easily used within LangGraph as kind of your agent orchestration layer. But LangGraph can be used without LangChain. It's completely independent. It's also open source. This is just showing that the two do play well together, but LangGraph can be used completely independently from LangChain. That's another very important thing to note. And this is just kind of highlighting some of the benefits of LangChain, but of course you don't need to use it. You can use whatever you want to, for example, for accessing LLMs or different components within LangGraph. So first, let me just kind of show a few different kind of architectures and how they kind of look in LangGraph. So this is looking at visualizations in that LangGraph Studio app I showed you of a few kind of common types of agents. Now, this is a very simple router where we start. We go to this tool calling LLM node. That LLM decides to either call a tool or not. Okay, that's a very simple example of a router. And this is kind of how it looks in LangGraph Studio. Now, here is a general tool calling agent, which is kind of on the other extreme, where basically you have an LLM that's connected to a bunch of tools. If the LLM makes a tool call, it goes to this tool node. The tool node runs the tool, returns that output to the agent, and this can kind of repeat, arbitrarily long until the assistant of the LLM doesn't make a tool call. So these are two different common agent style architectures that you can build really easily as graphs, where each of these kind of boxes represents a node, and these lines represent kind of edges or connectivity between the nodes. You can build them very easily in LangGraph. Now, what's nice about graphs is you can also significantly increase the complexity without losing kind of reliability. So this is an example of a RAG agent that I built, and it all runs in LangGraph. I share some of the videos here, which you can see in the slides. And this is combining a bunch of ideas related to advanced RAG, including query analysis, where you have a question that comes in. You have a query analysis node that looks at it, decides, is it related to the index or vector store, or is it related to or is it just relevant to web search? So basically this routing takes place first. It routes to web search or it routes to RAG. If we run RAG, it then also grades the documents for relevance to the question, and it grades the answers for hallucinations and answer relevance. So this particular agent for RAG, which I built in LangGraph, is reliable enough to use with open source local models even, because LangGraph kind of restricts the flow, as shown here, to this series of steps that are very clearly enumerated such that the LLM has to make only pretty simple decisions. Like, for example, in this query analysis node, the LLM only has to decide where does the question go? Does it go to web search or vector store? And in this grading, it only has to decide, is this document relevant to the question? So when you basically take your kind of agent kind of like workflow or logic and lay it out as a graph like this, you actually can get really high reliability because it's very different architecturally from giving a single LLM access to a bunch of tools and letting it choose those tools in any order. Here, the flow or order of the application, I enumerate and lay out in the graph, which can significantly improve the reliability. That's kind of the key intuition. And this also shows how flexible building agents or workflows in LangGraph is. You can lay out many different types of workflows as graphs and use LangGraph to orchestrate them as shown here with a kind of complex RAG agent. I linked some videos here. We have tutorials for a number of different use cases like customer support and so forth. So I do want to walk through some of the pillars. Now we've kind of established that you can use LangGraph to build kind of common agent architectures like routers or kind of an autonomous tool calling agent. You can use LangGraph to build very, very custom agent workflows like I just showed in that RAG example. Now let's talk through some of the kind of more advanced features or pillars that you can use and incorporate with LangGraph. So first is the idea of persistence. So LangGraph supports both short and long-term memory. So short-term memory is just the memory of an agent within a given kind of session interaction with a user. So you can think about the case of conversational RAG or a chatbot. You want the ability for the agent to remember the context of the conversation as a conversation proceeds. That's kind of short-term, what we call short-term or in-session memory. Alternatively, there's the idea of long-term memory. So the distinction is long-term memory is basically if I have a session, for example, a chat with the agent, me, Lance, being the user, I then come back several days later and start a new session. I want information to be transferred from the old session to the new session. That's the notion of long-term memory. So it can be information that is namespace to me as the user or other things. But basically, it's the ability to store information specifically so that's accessible in future sessions of the application. It could be user-specific information you're storing, or it could be other things, like maybe you have a RAG application and you want to store every question answer paired ever asked, so you don't have to re-retrieve for the same question, even if a different user asks it. So LangGraph supports both of these types of memory. We have a template that we've put out recently that shows how to do long-term memory, and we actually show it in a few different ways. One way in particular is we show how to build a memory service with LangGraph. So that is basically you have an application. Here's an example of a chatbot where you're interacting with the user. And as this interaction is occurring, the application can call the memory service and save specific things to it, like user-specific details. The memory service logs those details, and those details are accessible, for example, as memories, with any future interaction with the user. So we have a nice template here, and this shows you how to do this using LangGraph. And this is all built into the LangGraph API, so it's accessible if you're using LangGraph Studio, which I showed before, that IDE, or we even have a way to deploy LangGraph agents, and this memory service is directly built into what we call LangGraph Cloud, which is our deployment service, and I'll be talking about that a little bit later. So LangGraph has strong support for short-term and long-term memory. Now I want to talk a little bit about human in the loop. That's another kind of very important concept that is part of LangGraph. So one of the interesting ideas that's come up when building agents is sometimes I want to have a human review, for example, what the agent has done. That can be to approve certain things, like approve use of certain tools. Like, for example, if you have a tool that calls a database, that can be to edit the agent's state. So, for example, if you want to change something that the agent has logged, you can do that. And LangGraph has very good support for human in the loop at any node in a graph. So here's a toy example where this tool calling node basically has a human approval kind of check built into it. So what happens is I can very easily kind of lay this out in my graph. Whenever my assistant calls a tool node, it pauses and waits for a human to approve the tool call and then proceeds. This is a really common pattern that we've seen repeatedly that people kind of have strong demand for, and LangGraph has native support for this. So I show some nice documentation here, as well as some interesting templates that utilize human in the loop. Now I want to talk a little bit about advanced controllability. So LangGraph has support for building many types of kind of multi-agent applications. That's one of the most common kind of use cases for advanced controllability. So people want the ability to kind of spawn multi-agent teams to accomplish tasks. And here's some of the common kind of workflows or like kind of design patterns we've seen. For example, you can have a single agent with access to many tools. That is kind of that's kind of like the base case. But you can have kind of a multi-agent unconstrained pattern where any agent can interact with any other agent. You can have kind of different patterns of like kind of a multi-agent workflow where kind of one agent starts. This is a very common pattern that I've seen and used quite a bit. You have a multi-agent supervisor where you have one kind of like master agent that outsources tasks to a number of other kind of sub-agents that accomplish tasks and share the results back to the supervisor. So any of the pointers, there's a bunch of different kind of multi-agent style kind of workflows that you can set up very easily in LangGraph. I'll show one example that's just kind of fun that we've set up in our own office. So for example, this is a nice kind of demonstration of the multi-agent supervisor. Here's the problem statement. It can be generalized to many types of problems. I have 12 different teams for fantasy football in the office. I want to produce like a news feed of kind of relevant news for each team. So what I want to do is I want to look at news sources and I want to jointly get a list of all the different teams. Now for each team, I want to do an individual kind of scanning of the news for those players. And then I want to publish all those results to a common feed. So we actually do this where we have the kind of a node in the graph that loads all news sources and also loads all the teams in the league. Then for each team, it actually goes and spawns an individual agent that looks at the news sources for that particular team and produces kind of a summary of the news for players on that particular team. All those like takes are then kind of accumulated and published to a common Slack channel. But this is a nice example of that kind of, if you go back one, that kind of multi-agent supervisor, where you basically have a single agent that spawns the job of gathering news for each team to 12 different sub-agents that each do the job for the individual team. That's all parallelized. And then that result is all kind of accumulated and then published out to a Slack feed. So it's a very simple example. And here's the repo, for example. Here's a very simple example of kind of that multi-agent supervisor style workflow. We also have a very nice example of this in LangChain Academy, which is a course we have for free that basically provides a from scratch introduction to building agents with LangGraph. This is a slightly different use case. But it actually combines a few nice ideas. One is human in the loop to basically start with a question from a user, spawn a bunch of kind of sub-researchers to investigate different aspects of that question. And then basically each researcher will basically do research independently. And you can think of each of those as kind of individual agents. So again, it's kind of that supervisor multi-agent team approach. The research is performed in parallel. Results are aggregated into a final report. This is another example of this kind of multi-agent supervisor paradigm. And we have a very nice kind of notebook and also full course that kind of tells you how to build something of this degree of kind of high sophistication. And I do kind of want to just note kind of where LangGraph sits within the overall kind of LangChain ecosystem. So LangGraph and LangChain are both open source libraries. LangChain is a little bit different in flavor. As mentioned, LangChain features a large number of integrations with third-party providers for common AI components like chat models, like vector stores. LangGraph, on the other hand, is an orchestration framework, which can use LangChain, but doesn't have to. You can deploy anything you build in LangGraph through LangGraph Cloud. And you can also use LangSmith, which is kind of our observability and evaluation framework, to monitor and test any agent you build in LangGraph. I do just want to note very briefly kind of this notion of agent evaluation. So you can kind of do this 3 different levels. One level is actually performing checks or self-corrections within the app itself using the application logic. That's, for example, that RAG application I showed previously is a good example of that. Where you can kind of in-app error corrections. You can also do pre-production testings. There's many different ways to do testing in LangSmith, which works very seamlessly with kind of agent built in LangGraph. And LangSmith also has production monitoring. So you have an agent, you deploy it. There's lots of different ways you can kind of monitor that agent production using LangSmith. So that's just another thing I want to note. And just as a final point, that you can also deploy agents using LangGraph Cloud. So if you build an agent in LangGraph, you want to actually deploy it, we do have a cloud environment that supports that and is a very nice seamless way to take something you've built in LangGraph, you've kind of debugged it in LangGraph Studio, you want to deploy it as a service, you can then do that with LangGraph Cloud. And I just want to kind of make a final note that we do have a free course on LangGraph that goes from scratch, kind of how to build agents using LangGraph from scratch all the way up to a pretty sophisticated multi-agent system capable of research, which I showed previously. So this is, of course, free and highly recommended if you want to kind of get started with LangGraph and learn kind of from scratch some best practices for building agents. And that's it. I just want to leave you with that. And thanks for the opportunity to speak.